Bibhrajit, a lot's changed since we had you on here. The market for autonomous equipment and construction and mining has changed dramatically. What is the current state of the market?
Yeah, before do that, one thing hasn't changed. You look the same, beautiful. So that you look like ready to go. When I seen last time, so great to talk to you. I think the market wise, just to kind of give you, we are playing in the mining and construction field, right? The interest for autonomy has even gone up. Like you cannot talk to a mining company, and all they are saying that when can we get it done? Can we expand? So I think interest is massive, whether it is mining and construction. We also play into quarry market like a cement. So massive interest. Getting customer is just they want it now and they want it done today.
They want it done today. Is that being driven? I'm speaking to a lot of construction executives, and they're saying labor. Somebody shows up, they might be there an hour, they might be there a day, and it's a flip of the coin. So they're going to come back the next day. Is that one of the driving factors, the labor, of why these companies are looking to embrace autonomy?
Absolutely, the labor part of it, the what you just mentioned, the having the reliability that I'm going to be able to do this job in this time frame reliably, because the market for whether it is construction or mining, and you can observe like all those metal prices going up, the huge boom in the construction, they cannot keep up with the demand across the globe. This is not just US, across the globe. So really want it, and I think the another thing is that productivity improvement. It's not just a autonomy legitimately give about 20 to 25% productivity improvement. We will talk about it. In the construction area, they might say, I run 8 hours now, but I will be able to run 10 hours. I'm only doing 5 days a week. I'll be able to do 6 days a week. So I think there is a huge amount of productivity improvement, which in construction, that is a layer of implication that instead of finishing the project in 2 years, I'm going to finish it in 1.5 years. So I think the market understand they just wanted to get it done now, and the onus is on us, all the technology provider and who providing this solution to get it to that in the field safely and do it productively.
Do you have enough capacity to meet market demand? Is there overwhelming demand for you, and that you have to keep building your company to meet that demand?
Yeah, we are definitely capacity constrained, not just us. We are too constrained, right? Technology, I would say, not 100% to the T is ready. If really a customer comes to us or any of us, any of us say that, give me 100 of those. I think none of us quite ready to say, here is 100, go. And I have the support, I have the service, and it's just going to work the way you will expect to buy a finished product. So that's the one constraint. And also, yes, there is a capacity constraint in the industry itself, but we are also pretty constrained in that way. We would love to. I think I was talking to you before. We are in Australia. We are running in US. We are running in Japan. We are talking in Canada and Latin America. But I just cannot go there as of yet on the capacity constraint on our side.
When you do have the capacity, then you'll look to expand into Latin America and expand into Canada.
100%. I think the way we are looking at it is that how can you expand almost like not organically, but can you expand to the partnership? Like when you go to Latin America, do I have a extremely strong partner who have been in an industry serving this industry? Can I partner with them where we do the technology, they do the operation side of it? And that's really the winning formula. You cannot possibly go to Latin America. I say Latin America, but it's not a one country. There are like 6 7 countries packed into that. You possibly are not going to all of them yourself. So I think we will grow fast, but through a partnership along with our team as well.
When you look at partnerships, is that a local construction company that you're partnering with, or is this you're partnering with a dealership to get the technology on retrofitted trucks? What does that look like from a partnership perspective?
If you look at, I mean, it's different for construction and mining. If you look at construction, look at a mega construction project, there are a lot of subcontractors, right? And a job actually get done by, I would say 85% job get done by a layer of subcontractor. And then obviously they are renting stuff from different rental, they are renting stuff and are getting stuff from the dealer. So they are really, that group of people is really doing the construction. They are running the show, they are actually doing things, they are getting the vehicle. We will partner with them. So maybe in the construction phase, we'll partner with a mega subcontractor or a rental company or a dealer who is basically have boots on the ground, been there for a long time, doing this thing. We just tack technology on top of them. Their existing ecosystem is already there. That ecosystem has built over last 30 40 years. We won't be able to build it overnight. And that's the way to accelerate. And that's what you're doing. I mean, whether it's construction, it's a subcontractor, dealer, or rental company. On the mining case, it is the dealer. It's a, they also have the service companies across the globe. So service companies OEMs are also in the mix. So that's kind of your makeup of those partners.
When you look at Canada, especially in the middle of the country or northern Canada, going up into the oil sands, and you look into certain parts of, I spent time down in Latin America. There are some very rural parts where there is active construction going on. How do you get the connectivity that's needed for your system to operate in these remote parts of the world?
That's a very good question. And one thing is that it is not, a lot of people think about, it is not difficult to get connectivity in remote parts. The problem is that I can get a private LT. You throw me in the middle of Canada, middle of nowhere, I can get a very reliable connection, but it will cost me a lot. So just to give you a sense, if I have a mid-sized mine, it will cost me about $3 to $6 million just to set up a nice private LTE. Now, I do not have a $6 million to spend every time. If I have a mid-sized mine, I'm going to run for 5 years, right? I don't have enough time. If I have a mine that I'm running for 40 years, big mine, I will be able to spend that kind of money, right? Because I'm going to amortize. But what is happening in the communication on the network side, the cost is decreasing significantly. I think we talked about what used to be $5-6 million. Now we can get a reasonable network in a remote site for about 400 to 500K as an initial setup. Then you pay yearly kind of maintenance and licensing fee. One of the thing, like a wild card, we are testing out both in Japan, US both side, is we are testing out Starlink, and we are excited about it. Obviously, we still have to prove out Starlink works, but if Starlink actually work as a connectivity in these remote parts, all of a sudden your cost goes down to less than 100K, and your yearly cost is somewhere around, depending on how big your size, less than 100K. Now you're in game. You can definitely spend that kind of money instead of a $5 to $6 million. So we are excited about it. I think cost of the network coming down, that will enable this site, not just autonomy, but also another thing that's happening, the digitalization and connectivity. I think that will also accelerate.
Starlink is going to change rural construction, rural mining, rural agriculture. We can look at John Deere is actively testing Starlink now in various different parts of Brazil. In a hypothetical world, the Starlink works. The latency meets all the requirements. Will that allow safe AI to scale faster and into to new regions, especially if you go into, say, Western Australia, with a lot of mines, or you go into various different parts of Japan where there is connectivity? Will that allow you to scale faster?
Absolutely. And I think that will also enable the customer to think about they are ready, because network and connectivity is one of the component that they need to make sure that is working in that side, right? So it is allow both the customer, our end user, and us to go faster. And I think Starlink is a game changer. I don't know if you saw recently this little clip of video. I think it's a Qatar Airlines. They had their CEO, whatnot. They had a like a Zoom call with Elon, with Starlink, in like two Starlink going on, and they're providing Starlink all in Qatar Airlines apparently. I think that's a, you can see the game changer part right now. You literally have a, you can do a Zoom call while you're flying. So you can how talk about remote location, right? So obviously we can do it in a different sites in construction or mining, whether it is US, Latin America, Canada, Australia.
It unlocks so much. I did see that video of Mr. Musk and the Qatar CEO, and Mr. Musk was on Starlink on his end, and the Qatar CEO was on Starlink. It was end to end, not to get into neural nets, but it was an end to end Starlink connection. What are your thoughts on end to end? There's a lot of debate in the industry. Google, Waymo just published their Emma paper. Wave is taking an end to end approach. Wabi's taking an end to end approach. That's taking an end to end approach. You have experience from Caterpillar, from Ford, I believe Apple too. You had to stop there along the way. What are your thoughts on this, on these end-to-end models that are evolving?
So just to kind of, maybe I know you are deep into this thing, for broader audience, what is that end to end you are talking about? Basically, you are saying that your sensor input comes, you have a big gigantic AI model, and it is spitting out the final results, how to drive. That's kind of the context from the in the end to end. I think if you're gonna take a step back, where we start from back in the days, 2007, 2008, 2010, there was barely any AI, all hand coded. Everything from control, planning, perception, everything is hand coded. Over the time AI comes in, mostly took out the perception, saying that if you're doing perception, AI is the best, right? This is where CNN, DNN, age was there, but control and logic planning part was still hand coded. Then you got that era of Gen AI, and the more fancy algorithm comes along. They're like, why do we even need to do the other one hand coded? So what all of this company doing, and Tesla, Waymo, Zeus, all of them, they're slowly taking things out, putting AI back. But the way you do is almost like a baby step. You don't completely replace. You said, my hand coded algorithm is fine. Now let me put perception is all AI now. There is no more hand coded in perception. So that's already taken care of. It's a planning and control. We are saying that, okay, let's say focus on the planning. I have my hand coded algorithm. Let me put my AI algorithm parallelly and let me listen to both of them and give it a little bit of time, see how AI algorithm is doing compared to my hand coded, and then slowly take the hand coded out when you feel comfortable with the AI. I think that's what's happening right now. If you open up Waymo or Tesla or any of them, you will see they are both existing, and they are very judiciously making the call when slowly take off the hand coded one and rely more on the AI. And it's been happening in a very judicious way. Lots of thoughts going on, lots of analysis going on, lots of data going on, but eventually it will get there. But we in a sense of not just FAI as invest in very small approach, because we can see it is happening. So that's kind of where the industry today is as a broadly.
We had on the Alphabet earnings call, Mr. Sundar Pichai talked about, I believe it was 20% of the code that was written at Google last quarter was generated with AI. It's really fascinating. When does end to end work its way into construction and into mining? When do we start to see safe AI? I'll use the term experiment with it.
Today we use, so really perception and planning as a two different chunk, right? And that's a two different main work, right? Like, think about what you do. You use your eye to see what's going on, then you use your brain to decide what to do with your driving, right? Your hands and feet are just a control, just executing your command, right? So that's the kind of analogy, if you will. Now perception has been AI all day long, so that's including safe AI, including all of us, right? That's been done long time ago. It's the planning is the new territory where AI is chipping in, where AI was not quite there yet. So I think where we are as a safe AI, if you think our decision point, we have three type of decision point. One decision is that how to drive from point A to point B. That's your one decision point. Second decision point, now let's say we're getting loaded. We back up to a loader. Now we have to make sure how do you manage your bed, how do you manage your arm, basically the actuator level control. This is not your autonomous robotic, this is more of an actuator level robotics, right? Because I'm moving bed, I'm moving my other thing. So that's a different level of, that's your more of a reinforcement learning, kind of learning to do the job, right? You see a lot of this cool video, I'm trying to pick up something, I'm trying to crack an egg and all the thing. That is really the second type of planning. Third type of planning is that I'm playing with the other player now, like I'm backing up to a loader. So it's a multiplayer decision playing AI, but I'm saying that not only I need to know what I am going to do, but how do I play with this other actor who is interacting with me, in this case a loader. And it is critical, right? I'm backing up very close to the loader, I have to be exactly right place where it don't load me, I have to get out in the right time. So I think we most of our algorithm for the planning is still hand coded at this point. We are putting the AI parallelly. We haven't give AI right to use it. We are just seeing how it does. So all three area we have the AI. We are seeing how it does. But currently, for us, we are running the hand coded mostly, seeing how the AI does. As it get mature, we will slowly do the same thing. What Tesla or Waymo has been doing for last 2 years, we are just at the very beginning of that journey.
We're at the beginning of the journey, and you alluded to it, and I'll say it. At some point, it's going to happen. Another journey that we're seeing in the market is a big shift away from LiDAR being the predominant sensor. The engineers I speak to say that because we've had incredible breakthrough with depth sensing technology with cameras. What are your thoughts on the sensor stack today? And as you eventually move your way to end, well, that's sweet change as you advance the technology.
This is like almost this is a debate like Android and iPhone debate, right? You cannot win. Like, you can debate through the through the end of the ages, but I think you want to kind of separate this debate into two things. One is the pure math and science part of the debate. Another is that, okay, what is it for commercialization? They are not the same debate, right? So the pure math and science is that camera only is more than enough, because I got enough information coming out of camera, and which is, Elon Musk makes that comments all day long, which is on a physics level, it is the right information. Like, your eyes doesn't have a lidar, simple, and you are doing fine, you are driving fine. Yes, we are having 36,000 fatal accident in a year, but that's not because of our eye problem. So your eye is fine. So information wise, science and math wise, camera is perfectly fine. Whether your AI algorithm is smart enough like our brain to decipher that. But the commercialization is different. Commercialization for our world, think about mining and construction, we are less sensitive over the total BOM cost, bill of material. And we are saying that because our camera based AI perception is not to that maturity that I like to be, so I'm going to use LiDAR just because I want to be more confident. My customer is not going to penalize me for putting a LiDAR in the truck, but they are going to penalize me if I don't drive 24-hour constantly reliably, because the vertical is less sensitive to the pricing of the components, are more sensitive about the reliability and the operational efficiency. I am going to use LiDAR because I can. That's the one. We are using LiDAR, we are using camera, we are also using radar. That being said, if you project us another 10-15 years, eventually we'll strip off the LiDAR, we'll only go with the camera. But that's a long tail for us. We are not under the gun. Now, if you shift to the robotaxis of the world, or just a regular car, your car is not a $500,000 truck. We work with a $500,000, we work with a $5 million truck. $500,000 truck is the smallest for us. But your car is about $50,000, $60,000, $70,000. You possibly cannot put a $10,000 LiDAR in there. It's just not going to happen. Whether you need it or not, you just cannot do that. So I think that's another argument. Commercially, it's not viable. Waymo is doing it because they're not selling the car to you. So I think eventually the pressure from commercial, and at the same time from the science wise the camera alone is good enough, you will see the road will converge, because you commercially you cannot put a 10,000 or even $5,000 LiDAR on a $70,000 car. Just not possible. That logic makes sense. There is a two different logic.
It won't scale. I was speaking to a very large institutional investor this morning around Tesla and Waymo, and I got access to a research report I read, and I'll credit this to Evercore. It said based on Waymo's last funding round of $5.6 billion, $5 billion of that, I believe, based on filings, was Alphabet, with $600 million coming from Tiger, Silver Lake. And this report that I read said that buys Waymo roughly 2 years of runway. $5.6 billion for 2 years of runway. You can't get very far. And if you look at the way the cost structure is, all the sensors, I don't see how Waymo's going to achieve profitability. But on your side, on construction, you're taking a $500,000, 5 million, million and a half. You have the margins to put all the sensors on there. Do we see more sensors on the construction mining because of the environment you're operating in, and then on the passenger stuff moving away to less and less sensors just because of the cost structure, and where the costs really enter the picture?
There's a lot of complicated math going on there. So let me kind of maybe start with the Waymo part. I think people, as much as you said, that is true, but there are few. I say there are few companies of the in the world, which is Waymo included, like Google included, Alphabet, Apple, Amazon, Microsoft, and few other companies in the world. They don't play by that normal economics rule. I think, like, the rest of us are the mortal human being. They are not. They can say, I can spend $20 billion, I can dump into the water all day long, I'll be still fine. So I'm just saying, I'm not saying they're going to do that, but you cannot quite equate the same economics you're going to equate to Ford to Alphabet, because it's just a different dynamics, right? If they play in Apple, play a different game. Like Apple took, like, Apple car, right? They almost burned $20 billion. If any other company would have burned $20 billion and put it into the water, their stock will get a huge hit. Apple didn't even, you didn't even see that in there. Like, it didn't even show up. So I think, can Alphabet keep going? Yes, they can keep going as long as we do their search, as long as they do their main thing. 98% revenue coming from search, they can do all these things. So I would not count count Waymo out because of financial problem. I'm not saying they cannot, but finance is not their problem if they want to. So that's the one side. I think in the heavy industry, we still gonna use LiDAR camera. One is because our customer are not sensitive to the pricing of the BOM, right? But they are sensitive to the operation. We're gonna keep using it. But also our maturity of technology is less. In the heavy industries, AI algorithm is not as mature as Waymo and Tesla, just because we are not putting that much of money into this. So we think about our AI is less mature, so we're going to rely on LiDAR a little bit longer, and our customer saying, yeah, you can do that. So it's a very rational, that's the combination. In the robotaxis and passenger, Teslas of the world is different, Waymo is different, because Tesla is selling you a car, Waymo is selling you a ride. if they can squeeze the cost of the ride as same as the Uber driver. Like I take ride in San Francisco to Waymo all day long. I love it. I will, if it is the same cost, I will actually even pay $1 more. I don't mind. But let's say regular passenger, if I can give you the same ride at the same price as Uber, you will take Waymo all day long. You don't even
Mhm.
need to be less because it's such a better experience. So if they can say, okay, that's my capex, I'm not going to pass it on to my customer. I just need to make sure my mile cost is, if I'm charging, if Waymo, if Uber charge you $10, I charge you $10, my cost is $8. I got a $1 trillion business. So that math is different for Waymo, and Tesla is different. So I think they are not quite same because the dynamics and the commercial is not quite same for Tesla and Waymo.
You look at this, I'll highlight this. Ford at current market price, records on Friday, November 1st. Current market valuation of Ford is roughly $40 billion. Waymo's last funding round is $45 billion. Waymo's worth more on paper than Ford. Pretty dramatic. When you staying on the Waymo theme, if you look at Waymo is taking the same route that you're taking, a retrofit. The Firefly went into retirement and it moved into the Computer History Museum. Why are you taking this at Safe AI, this retrofit approach to autonomy? It's the same one that Waymo is currently taking as well.
We have two reasons. One is that there are, just to give you a broadly number, there are about over a million different vehicle in our industry, like a heavy industry broadly, about a million. Like I'm including everything: mining, construction, agriculture, all of it, right? Like as a, and today there is only 2,000 of those vehicles are fully autonomous out of the factory. So when I go to my customer or my end user, they already have the vehicle, they want to make it autonomous. So just by the customer demand, when they are buying a new truck, yes, but they have already a existing fleet of machine, they want to make it autonomous. So it's a naturally customer demand. Second thing, they also want to do mixed fleet. They don't have one type of vehicle, they have all kinds of vehicle. So really for us, retrofit is a market driven decision. It's not really our decision. Like I have to do that because my customer is demanding that. Over the time, and that over the time might be 15, 20, 30 years or 40 years, you will see most of this vehicle factory fit will be autonomous on the get-go. But that will take some time. It takes a long time, and it's not a 5-year window, it's a 25, 30-year window. So yes, we are doing retrofit because that's a pull for the market for the time today. But eventually, if you give yourself 30, 40 years, most of the vehicle will be autonomous out of the factory from the get-go.
When we do achieve that in the 30 to 40-year time frame, will Safe AI explore an OEM deal at some point in the future when the market is mature enough and your company is mature enough and ready to do that?
I think we will consider even way before. So basically, the way when I say it will come out of the factory, it will come out of the factory even at the. It's not like boom, 30 years, all of them are autonomous, right? It's going to be slowly. You can see more and more model available, and just going to ramp it up. And OEM thing will be our software will be integrated into their truck on the factory itself. We will continue to do retrofit. We'll continue to do factory fit. Over the time, retrofit will be more, factory fit will be less. Eventually your factory fit will take over retrofit, and retrofit will die down. So that's like the, I'm kind of painting a 30-35 year kind of time horizon how it will play out.
I like long time horizons because they're stable. Are there a lot of the heavy machinery is drive by wire just because of the design and how large these vehicles are and can be? Are there any limitations or different types of vehicles when you go to retrofit them today that you cannot retrofit for a technical reason, perhaps, or just a overall size reason?
There is not a technical constraint. It's really, it's an engineering. Like every new vehicle you do, you gotta figure out how to do this. There's just a detail level engineering, that the harness design, this thing, that thing, but there is no technical reason. And most of the vehicle, usually like a life of this vehicle is about 15 plus years, 15 to 17 years. Most of this vehicle we touch are, that basically, as old as 10 year, they are already have the more advanced, basically their brake throttle are already by wire, none of them steering is by wire. So technologically it's very much possible, but yes, it slows us down because each vehicle we have to kind of spend engineering hour and time to make it ready. But I think as the OEM start making them out of factory all ready to go, we won't have to spend that time because it's ready, it's almost going to be ready.
So, in other words, the vehicles coming out of the factory could be quote unquote autonomous ready.
Yeah, so the I think the in the passenger world they call it a AV friendly. And in our world, we an AV friendly vehicle, and in our world we call a open architecture friendly. That's just a different, same thing, different name. And you can see some of the OEM already been doing it. I know there is a company called Bell. They are started to make the new model of the vehicle already autonomy friendly. Same with the larger OEM. Some of their model, they are already saying, okay, this is, they're slowly inching in, and eventually it will be the norm in the industry.
In Australia, you modified a Hitachi EH3500 where you've hauled 13,000 tons of topsoil fully autonomous. When you first take the Hitachi truck, what do you do? What's the first thing you do when, okay, we're going to make this autonomous? What is the first thing that you do?
So really, I mean, I think first thing we look at the overall the manual, right? What the truck's makeup and shape look like, how the brake work, how the throttle work, how the steering work, who is controlling the bed. Bed means the bed goes up and down. Who is controlling the accessory? We kind of get a sense about what is going on, right? When I'm pressing the brake, what exactly going on in the vehicle? How am I stopping the vehicle? Kind of get a full picture of that. Is it a CAN signal? It is a hydraulics going through. It is a valve going through. We get the full idea of that, right? Then I say, okay, I do not have that human operator in that cab anymore. I need to press that brake. What do? I can physically press the brake, which is not a very pretty design for mechanical, so we don't do that. So when I press the brake, that signal goes to somebody. Is a CAN signal, is a hydraulic signal. I say, instead of pressing the brake, can I tap into that person or that portion of that logic and directly send a signal to them? So that next module would have gotten signal from the brake pedal push. Instead of pushing the pedal, can I send a signal from my controller to that module to say go do that, and then downstream we are all good. So that's really what we do, is that who is my next element who is receiving that human input, and give them that input in the same channel, whether it's hydraulics or CAN or whatnot, serial bus, give them the same information so they would not even know where it's coming from. Then I'm good to go. I have a electronic way to control the same vehicle that I would have done it with a human way. So that's the first order of business. If you're gonna go from there, second order of business is that, okay, now I gotta put all those LiDAR, radar, camera in the different places, put the computer somewhere. The computer cannot get overheated. Like just that mechanical engineering design of it. Where can I put those? What's the right place? Where can I put my computer? It doesn't get overheated. How big the computer box can be? All that design with the idea that it should not. We always assume there will be a human driver, should be able to also drive if need to be. So make sure we don't, kind of block them anything, which is the law today in both Australia and US. So that's kind of the second order of business, putting all this hardware into the vehicle in a very neat way.
Did you have to build your own drive-by-wire kit, or was that already available in the vehicle?
We had to do it, and it is, we have our third party vendors and our partners to do that. But no, we had to do that on that part of the drive by wire part.
Then how do you determine where to put the sensor, since obviously some of these trucks are shaped differently in terms of size?
We have a very detailed simulation tool. We use the simulation tool to kind of do a think about the field of view analysis. So we can say, okay, if I'm putting my LiDAR here, camera here, what is my, how far do I want to see? What is my block view, right? I still have some of the view, like some of the area I cannot see. Like I want to obviously minimize that. So really we do a detailed simulation analysis, and this is where simulation tool come very handy. We use, applied intuition for our simulation solution. It is, we talked about it. So we use simulation pretty extensively to do this field of view analysis. And obviously then you have to go to physical truck to make sure sim to real is still, but this one simulation does a very good job because it's a static analysis, right? You can put it in a different angle and run it in a simulation. So that's the way we do it.
Then when does redundancy enter the picture? Is that pre-planning? Is that enter at this stage? When does redundancy enter the picture?
So redundancy in the sense of our visual redundancy, like am I seeing this area both with the LiDAR and camera? Maybe even in two camera there is overlap. So those are part of the decision because I want to see the same area with a different modality of sensor. This is where my kind of the robustness come from. I can validate each other. So there is this one set of redundancy. Another set of redundancy in the algorithm itself. I use different algorithm to come up with the same solution, but then I validate them. I will give you one example on the algorithm. I am using GNSS, like GPS GNSS solution to know where I am. Parallelly, I use also a camera and LiDAR perception based localization. It's basically saying I know where I am in the map. I can see where I am with my camera and LiDAR. I can do a map matching. I can say where I am. Now I can compare what my GNSS is saying and what I my we call it a perception localization PBL. Compare them, and if they are always kind of agreeing with each other, that is great. When they start to diverge, I have a way to converge them and say, okay, go with this one. So that's an example of using multiple algorithm also to bring that redundancy.
You have the redundancy, you have the simulation, you have the physical build. What use cases when you deliver the autonomous truck to your customer? So in Australia, you move topsoil. What do you see any patterns in terms of use cases and how your customers are wanting to deploy the safe AI autonomous vehicles?
I think one of the things, the reason we have started with the truck, you can see we have done the truck, we started doing the dozer, we haven't done the loader. Truck pretty much does the same thing, whether it is a construction site, whether it is a mining site, or whether it is a cement quarry site. They all do the same thing. It's exactly same. They go from point A to point B, go to a loading station, get loaded, come back and dump. The variation comes is like, what is the loader look like? Is that loader is an excavator? Is that loader is something else? How it is loading? Basically, is it loading? And there is a lot of detail. Is it loading like I back up to it and it's loading, or it's doing the side loading? Sometimes there is a side loading, and what kind of dumping it is doing. That's all the variation. So there is a 3 to 4 type of loading. There is a 4 to 5 type of dumping, but this truck is doing the same thing irrespective of the vertical. That's why I actually went after the truck first. Truck is very homogeneous, doing the same job across the use cases. So truck is very friendly in that way. As you go to the other machine, they become more complicated because different vertical use that machine differently. A truck is very homogeneous use.
Is it just consistent, repeatable routes? Is that one of the big draws there?
It is not only, yes, it is very consistent, very repeatable, and it's literally kind of sometimes hold the flow of that site. So if I know how my truck is moving, I can kind of almost back calculate how am I doing on the construction side, how am I doing on the mining. Because if I know my truck is moving and moving this much of load, that I can pretty much calculate, that's a flow of my operational efficiency. So it's a very very good metric. So if I can give you 10% productivity on a truck, I'm literally adding dollar to your productivity pocket. So it's a very nice business wise. That's why we don't get any pushback from customer, do the ROI and all that. Because if it is running and if it is giving you the 10% productivity, customer will buy it all day long.
It's a win because of the efficiencies. You look at a lot of customers and you look at data. A lot of your customers and soon to be your customers, or in general, want electric. When does electrification enter the picture?
I think you see a lot of this news. I don't know if you're at Mine Expo. That's one of the largest expo for our industry, in the mining industry. There's also a version called Con Expo for construction. Electrification is the talk of the town. I think if you look at Caterpillar, the Komatsus, the Hitachis of the world, and also the end user, they're all really putting a lot of effort into it. Electrification is still a little behind in autonomy. They still have to figure out the commercial pieces of it, the pricing pieces of it, but it is coming. There is a lot of good news happening. We have done a truck electrified with our partners in Europe. So basically, we took a regular Cat 725, completely gutted it out, and put the batteries and motors with our partner in Europe. And I think we will see this more and more. So basically, autonomy is a little ahead, electrification is going to catch up. Eventually, they will converge very nicely. Industry wanted both.
What impact does electrification have when you're designing both the hardware and software? Because when you're going to run a lot of sensors, it drains the battery. So do you have to make a light version of this stack, or what do you do to preserve the battery? Because your customers care about one thing more than anything: uptime. That truck needs to be moving and hauling stuff.
That's right. I think we have a little bit of advantage in our vertical because our vertical batteries are, because this is a anywhere from, as I mentioned, right, the amount of they move 25-ton to 400-ton vehicle. What does that mean? They are hauling a huge amount of content. That means battery here, the load I am putting on a battery is very insignificant, even if it looks pretty big, but it is actually insignificant compared to the load they are carrying just doing the job. Passenger is different, right? Passenger, every load matters. For us, same way as our bomb cost is little, they are less sensitive. So the power I'm drawing from the battery, because I'm running my computer and all, even if it is a big from the passenger guy's point of view, for us is very small compared to their total load. So they have a problem like how do you recharge and all that thing more. regularly because their load is too high. Like think about a 400-ton truck going uphill 15%. That is a massive amount of load. You can put 5 NVIDIA, you still will not, have any. You will not draw enough out of that compared to what this truck's designed to do. So I think we are okay. Doesn't mean we can not optimize. We will optimize, but we are less under the gun to do that right away. We will do that eventually.
You get there. There's no doubt
Yeah.
about it. In your opinion, what does the future of autonomous mining and construction look like?
I think this is not today just my opinion. I have talked to probably 12 or 13 of the top 20 mining company. They all have their next 10, 15, 20 years of strategy built out. The statistics are that today 2 to 3% of the fleet in the world in mining is autonomous. You can kind of do that math. And out of those, as I mentioned, I talked to at least top 10, 12 mining company in the world. They all are saying they will take that number 2 to 3% or 4% to all the way to 40 to 50%. And that is literally in their 10-year vision, 15-year vision. This is like beyond what I think it will happen. These are the top mining company want to go there. I think so. What you will see if I just projected that out, you will see about 30, 40, 50% of the mining in operation are fully autonomous, right? Fully in a sense of certain equipments, not all of them. It will take some time to get all of them autonomous, but a majority of the portion will be autonomous, and it will accelerate because once the economics start rolling in, it won't be like a nice linear curve. It will be a pretty, I would not say exponential curve, but it will not be linear either. So it will be a better than linear, less than exponential, but you will see it will catch up. So most of the mine will be autonomous in a very nice fashion.
It's a growth market. Inside of, I love this now. Inside of market, there's all sorts of other markets inside of an overall market. From a geographical perspective, do you see certain markets evolving or adopting autonomous trucks faster than other markets, and why?
Simple. Yes, the answer is yes. It will be geography based, and it's a question of what is your labor cost. At the end of the day, Australia's labor cost to run a truck 24/7 is about $500,000. Yes, and actually sometime more, but 500,000 is a good number to, rounded number. So I need $500,000 just to run a truck 24/7. And if I go to a different country and their cost to run 12 hours, all they run is 12 hours, and that costs them 100K. Now you can see the economics. Who is going to get there fast? Obviously, the who is spending $500,000, who is going to get autonomy faster, push more, run it faster than who is running at 100K, right? I think it's come down to economics, but over the time, everybody will catch up.
Yeah, if you look at it, you're right about the economics because if you look at California, they raised the minimum wage in a fast food restaurant to $25 an hour. They're laying people off. They're closing restaurants and turning to automation because they can't afford the cost. And then they're raising the hamburger. It used to be $7, now it's $14. Oh, and the business is imploding. So you're right. You need autonomy to balance that. The higher the labor costs go, the faster autonomy is going to be adopted. We both know that. And then you're going to unlock a ton of efficiency gains. We're really excited to continue to watch Safe AI grow, Bibhrajit. You got something special going here. We've been rooting for you since practically the beginning. As we look to wrap up our conversation for today, what would you like our listeners and viewers to take away with them?
Thank you for that, and you've been doing an amazing job. I saw your other interview. I know you're deep into this vertical, so it's always great to talk to you. I think I can maybe repeat the same thing I've been saying, right? A lot of people, autonomy used to be hot back in 2017, 18, 19. Now, AI kind of, taking all the limelight. I would say that, this is a inevitable. It is coming. You can have all kinds of concern, problem, but, this is such a powerful technology, whether it is in our vertical, even at a robotaxi world, even at that area, it will come. This is a super powerful. It's fundamentally going to change the transformation, our transportation industry. Here, couple of year plus minus doesn't matter. So I think the message is it is coming no matter what. It takes time, so be it. But in our vertical, and it will literally make the world safer and more productive. So it's coming for better.
Autonomy will make the world a better place. Autonomy's here and autonomy's scaling. The future's bright. The future's autonomous. The future is safe AI. Bibhrajit, thank you so much for coming back again on the road to autonomy.